Okay, so we have a great presentation lined up for all of you guys. I want to thank you guys for joining today. This is, I don't know, we're starting to make some inroads here with this virtual recording and virtual meetups. I think this is our fourth virtual meetup, maybe the third, 3 or 4. But we're getting more practice at this. We're still, I would say, new, and we're picking up a few things. We're improving our recordings and how we show them and whatnot. So, but I appreciate everybody joining today. Like I said, we've got a great presentation lined up for you guys and a wonderful speaker. It's Get 90 Minutes, presented by Jesse Liberty. Jesse Liberty is a programmer specializing in Xamarin.Forms, C#, and their related tools, especially Git. He's the author of 24 programming books, of which I have some, a dozen Pluralsight courses, as well as courses for Pakt and Udemy, and he is the author of a not yet published novel. For more, see jesseliberty.com and jesselibertywriter.com, and listen to his podcast, which I have many episodes of, Yet Another Podcast, available in all the usual places. Jesse Liberty.
Hi, thank you. This is going to be very strange because I don't see anyone, and so I don't know whether folks are falling asleep or very excited. I'm going to assume the latter. This is Get In, and it'll be somewhere between 60 and 90 minutes, depending on how quickly we go and how much we dive into details. But let me say that we're going to start at the very beginning and then proceed through to some advanced topics. So if you're already an intermediate Git user, I think you will find that there are things here that are more advanced towards the end. And that was my dog, who you probably hear off and on as well. Okay, so let's begin at the very beginning. What is Git? And Git is a very popular version control system. So the question then becomes, what's a version control system? The way I think about it is this. In the past, before version control systems, if you were programming and you made a mistake, you were in big trouble. So what we would do would be to make a complete copy of an entire project every so often. And then if you made a mistake, you could at least go back to the last good copy. And Git does that for you in a much more efficient way, and much faster, and uses much less disk space, and has copies for you, depending on how you do it, quite frequently. And I recommend doing it quite frequently. It also gives you the ability to switch among tasks. So if you're working on a feature and suddenly a bug comes up, Git makes it very easy to say, okay, let's hold on to what I'm doing on this feature and go over to this bug. Now let's go back to the feature and continue on. And finally, Git works extremely well with teams. And we're going to talk about that some when we talk about branching. Probably the most important thing to keep in mind about Git is that most things happen locally. And we're going to talk about the difference between local and remote, but most of what you're doing will be local on your machine. Boy, is he loud. And the other thing about Git is that you really have to go out of your way to lose your work. Almost anything you do in Git can be undone. There are some central areas to think about when you're working with Git, and I'm going to go into each of these in some detail. The repository on your machine and the remote repository have a relationship that we're going to discuss. But let's start by talking about the work area. The work area is where your current files are. By current, I mean whatever part of the program you're working on. If you're on a branch, we'll talk about branches, then the current files from that branch. If you're on the main line, then it'll be the files from the main line. If you've gone back into your history, it'll be those files. There's always exactly one work area, and typically you have just one project in that work area. You certainly only have one snapshot of a project in that work area. And if you were to open Visual Studio or open up Windows Explorer, that's what you would see. You'd see the current files, and we refer to that as the work area. So the next area is the index or staging area. And the work path is to go from the work area to the index, and from the index to the repository. Now you can skip the index, but typically what you're going to do, or many people are going to do, is to have their code in the work area, take the files that they want to commit and put them in the index, and then go ahead and commit them into the repository, which sits on your machine. The repository holds each of the versions of your program. That's where everything that counts is held. And we'll talk about how you commit into the repository and take things out of the repository. The next major area, which is closely connected to the repository, is the remote repository. The remote repository is in many ways a mirror of your local repository, unless you're working on a team, in which case it's a mirror of everybody's repository. A remote repository is certainly not required. Git is a distributed system. You can make anyone's repository be the remote repository for everybody else. But typically you're going to use a remote repository in the cloud, and typically you're going to use one of the services that specialize in this. A very, very solid one is GitHub, which is extremely popular. Azure integrates Git with its entire DevOps, and there are others. The stash is a place where you can take the files that you're working on and, so to speak, stash them away. You don't want to put them into your repository yet, but you need to go do something else. And you can see that one of the problems is that you sort of have to know everything to know anything. So we're already talking about repositories and branches. We're going to get to each of those things systematically, but I suspect that I'm going to use some terms before they're really fully defined, and I'll try to avoid that. You can interact with Git through a GUI. This one is called fork. That can make the relationship among your files and commits and so on graphic and very clear. All of these GUIs, and there are many of them, have some limitations, but they are great for the things that you normally do day to day. Visual Studio 2019 now has Git support built in and can give you a tremendous amount of Git interaction that's very visual as well. The killer place to do Git, the canonical place to do Git, is at the command line. Anything that can be done in Git can be done at the command line. Now, the command line is usually pretty plain, but if you get PowerShell and then go to the URL that I've listed here, then you can easily set it up as you see here, where your current directory is displayed and your current branch is displayed. And as you'll see, it will also display whether you've modified any files, whether you have files to download, whether you have files that you've deleted, files you have to add, and so forth. So this is a great way to interact with the command line. I'm going to make these slides available on GitHub, so you don't need to furiously write down these URLs or anything else that I'm showing.
That was one of my favorite articles in recent time. I love that article and all the tooling that brings in. I've been using PoshGit for a long time. Probably, I'm a contributor to PoshGit project too. One commit. I love that project, and what a wonderful setup that article portrays.
Yes,
Yeah,
I
I
agree.
just currently started using it, and it's great. Probably about 3 weeks now, so it's great.
It's fantastic.
Okay, let's talk about how you create your repository. There are two basic ways to create a repository. One is to create it on your local drive and then move it or push it up to GitHub, if you're using GitHub, which we will be. The other is to create it on GitHub and then bring it down to your local drive. And it really is a matter of which you're more comfortable with. The third way, of course, is to start with an existing project, turn that into a Git project, and then push that up to GitHub. But we're going to look at creating a repository on GitHub and then bringing it down to our local drive. So let me bring up GitHub, which I've already signed into. And if you haven't an account on GitHub, you'll first need to do that. And then very quickly, you'll be set up to create a new repository. Once you've done one, you'll find the new repository button up here in the upper left. You click new, and you get this form to fill out. So I'm going to call my repository RVNUG Git. So is it R-O-A-N-O-K-E? Spell it for me. RVNUG.
R-O-A-N-O-K-E, yep, just like
that. RVNUG. Oh, look at that. That's a repository that's not been claimed yet. RVNUG Git. Okay, it tells you that's available. Next comes a description. I recommend that you do put in the description. This will be code and slides for Git presentation. Next is your decision between public and private. If it's public, anyone on the internet can come and see it. If it's private, it's only by invitation. Of course, I'll make this public so that anyone can get to these slides. Now you have a few choices. The first one is, do you add a README file? And the answer to that is yes. You always add a README file because that is what people are going to see when they first come to your repository. And it's there that you typically say what the project is and how to interact with the project, how to add to the project, and so on. So as a general rule, you're going to add a README file. The next, and the answer here is also yes, is do you want to get-ignore? Get-ignore says, I want to give you a list of file types that I don't want you to add to Git because I don't think that these file types should be shared. And they have get-ignore files for many, many, many different languages. However, if you're doing C#, I highly recommend that you use the Visual Studio Git file because it has a complete set of all of the types of files that you wouldn't want in your Git repository. And then finally, you have a choice of whether or not you want to choose a license. I will go ahead and choose the MIT license, which is a good open source license. You can integrate GitHub with Slack. I'm not going to do that, but I am going to go ahead and create the repository. That takes just a couple seconds. And now I have a repository. And notice in the repository, I have 3 files. I have my README, the license, which is the MIT license, and my get-ignore file. Down here is what they've given me for free in my README file. Obviously, I'm going to want to add to this, and you use markup to do so. And then here is the description line that I put in. Okay, the next thing that I want to do is make a copy of this repository down on my disk so that I can add to it in a very natural way, working locally and then pushing my changes up here to GitHub. And the way I'm going to do that is to come over to this button, which says code and has a little down arrow. Let's open that up. You have a few choices here. You can get an HTTPS URL. You can get an SSH URL. I'm using SSH, so you'll see how I use that. And I have a little clipboard here, which I'm going to click on, and that will move this URL into my clipboard. Also, if you have GitHub Desktop, it will just do all the work for you. And finally, you can download a zip to just have a copy of your repository at any given moment. Okay, I want this one. I'm going to take the clipboard, and then I'm going to open up my command line. And we are in my base directory GitHub, and I'm going to say git. Every git command begins with the word git. And then I'm going to say clone. And clone means please make an exact copy of this and bring it here. And then I need to tell it what I want to clone. And so I'm going to give it that address that I just put on the clipboard. And it's going to clone that repository right here locally. And if I look into, let's see, what I want to do is I want to change directories to rv.nug git. As you can see, that's right here. It's one of my directories. So I'm going to do that. And now this prompt tells me where I am, GitHub rv.nug git, and I'm automatically placed on what's called the main branch. The main branch will typically be a place where you'll only want work that has been approved, that has been thoroughly tested, because the main branch will typically be the branch that you'll actually do your releases from. Now, in larger teams, you might have a whole other kind of structure. For example, where I work, we have a develop branch, and then we have release branches. Some places have even more. They have testing branches and so on. And again, we'll get into branches more precisely as we go along. But we now have a repository locally that has the same material as on the remote repository. And if we take a directory here, we can see those 3 files are now local. Let's go back to here. All right. I had mentioned the staging area. If you want to move files from the work area to the staging area, you use the git command add. If you want to go from the staging area to the repository on your machine, you use the git command commit. Now, commit is overloaded. It's used in 2 different ways. One is to commit your files, which is what we're seeing here, and the other is a commit in your repository. So if I commit 3 files, what I've created is called a commit. And every time I do that, I create another commit. And you'll hear that terminology used quite a lot. If I want to go from my local repository to my remote repository, I use the keyword push. Every time you commit, you are required to put in a message. Those messages are very important because when you're reviewing what you've done, it's the messages that are going to give you the information about what each commit is, and that's especially important if you're on a team so that others can look at your commits and understand what they are. By convention, you put your commit messages in the imperative. So instead of added files, you say add files. And you try to make them as useful and that they explain more precisely what is in the commit. So rather than saying some files, it's better to say calculator class or whatever it is you've actually done. Now, if you get these wrong, you can clean them up later with something called interactive rebase, which we're going to look at. One of the things that we want to do right away is that we want to create a project to go into our repository. So let's open up Visual Studio and create a new project. I hate these menus. Project. Okay, to keep life simple, and because not everybody knows C#, I'm going to make a very, very simple program. I'll explain as I go what I'm doing in C#. We're going to make a console app. That's the simplest kind of application we can make. And we're going to go ahead and give it a name. So I always suggest that you give it the same name as your repository. And then we're going to have to tell it where to put it. So I'm going to go to GitHub, which is on here somewhere. There it is. And then I'm going to tell it to go to RVNUG repository, RVNUG git, there we are. And notice there's this hidden folder .git. That is your local repository. If you're curious, it's perfectly fine to open that and look at it, but do not touch anything. The one way that you can absolutely lose data is to touch or make any changes inside that folder. Okay, we're at the folder we want. We're going to select it. So we're all set here. We're going to say create. And Visual Studio creates the project for you, and it actually gives you a little bit of code right out of the box. So we now have this right line hello world. Now, if we go back to GitHub, we notice that it's not here. And this is your branches, and all there is main, and see, just main. And the files that we created are not here. And that's because they're sitting on your local machine, but you have not yet pushed them up to the server. In fact, you haven't even committed them to your local repository. They're just sitting in your work area. So we can fix that very easily. The first thing I do before I do any commits or any other big changes is I say get status. And that gives me a much better idea of what's going on. And here, what I see is that it says that I'm up to date, but I have untracked files. And a little unusual is I have actually a directory. It also tells you what to do. It says use git add file, and that will include what will be committed. That's going, when you add, that's going to put it into the staging area. So let's go ahead and do that and say git add RVNUG git. And we've now staged that. And you can see over here it says +3, and that's for our 3 files. So let's go ahead and commit that, which we do with git commit. And now it's going to want a message. And because I didn't put in a message, it's going to open up an editor. And I'll show you in a little bit how you can avoid this and make it more a little bit quicker. But we're going to call this initial commit for RVNUG project. Maybe not the best message in the world, but I'll live with that and save that. And now those files have been committed to the local repository. And notice here it says arrow 1. That means you have 1 commit to push up into the server if you want to move from your local repository. It is now in your local repository, but it's not on the server. If we went back to GitHub, you still wouldn't see it. But if I say get push, remember that's the command to take your commit and push it up to the server, it's going to determine that you have 1 that's different, and it's going to push that one up to the server. Now let's go back to the server, and we should see it there, but it's a little tricky to see it. Notice it's not here, and even if I refresh, it's not here. There it is. Excellent. So we have the folder for RVNUG git. We can actually work our way into that folder, there's the solution. Dive down, there's program CS. We can drill down a little more and actually see the code. And then we can bring ourselves back here. So we now have synchronized our local repository with our remote repository. And we are all set to use Git and to get to work. See if that'll work. Okay. Let's talk about branches a little bit. We were given out of the box main, and we have our first commitment in main, and we have this object called the head that points to whatever is the current branch position. And that's what's going to be, when you check out your branch, that's what's going to come into your working area. So we don't want, as I've described, we don't want to do work directly on main. We want instead to create branches off of main, do our work. That allows us to throw away the branch or change the branch, and then when the branch is the way we want it, we can add it back into main. So let's go ahead figuratively and create feature 1. And notice that head is now pointing to feature 1, and we can add additional commits to feature 1. Now, notice that there are additional commits to main. We didn't create those. Those were presumably created by other people on our team, and we'll see why that's an issue in just a moment. Here, we've created a second feature. Notice the commands in the upper left. Get checkout main, that takes out the main branch. Branch feature 2, which creates our feature 2 branch, and you would think now you're on feature 2, but you're not. You're still on main until you say get checkout feature 2. Now you can combine those two statements with get checkout -b feature 2, and that tells Git to create the branch and also to check it out. And since we just created feature 2, head is pointing to feature 2. If we were to check out feature 1, then head would now point to feature 1. And we can go back and forth as we check out those different branches. Once we're done developing on a particular branch, we want to merge that back into main. However, if you're working on a team, most teams are going to say, well, you can't just merge into main. Main is too precious a resource. Instead, what you're going to do is issue a pull request. And a pull request is just a way of saying, I would like to add this back into the main branch. Can somebody please review it first? And some teams require 1 reviewer and some require 2 reviewers and so forth. Once the reviewer approves, then the merge will go forward. Now, if you're using a whole DevOps setup, it could be more than just that you have to get past a pull request. Where I work, for example, it has to compile, it has to pass all of its tests, and then it goes to SonarQube, and it has to pass all of its linting, and if it fails any of those, then it is not added to the main branch. This now brings up two-way communication, because other developers might have added to the remote repository, for example, feature 2, and you may want to do some work on that, or work on bring down main, or for any number of reasons bring down a branch, and you do that with the keyword pull. That's from the remote repository to the repository on your machine. Now that it's in the repository on your machine, to get it into the work area, you use checkout. And those are the commands that you really need to know pretty much to use Git at its most basic. So you're going to use push and pull, and you're going to use add, and you're going to use commit and checkout. Not too much to remember. Over time, you'll see that there are many more commands that give you a great deal of flexibility. Okay, so here we are on feature 1, and we want to merge it. Now notice that you can draw a straight line without missing any of the commits, starting at the beginning up to here, and time works bottom to top, and the arrow indicates that when you create a new commit, you're starting with everything in the earlier commit, taking them into your new commit, modifying, adding, deleting, and so on. But we can go from main first commit to main second commit directly to feature 1 up through feature 1. And since this makes a direct line, when we're merging, we can do what's called a fast forward merge. And all that is saying is, rather than struggling to get feature 1 onto main or into main, we can just take advantage of this direct train. And now head is pointing to the last commit on feature 1. The feature 1 pointer is, of course, pointing there, but also main is pointing there. So if you were to branch off of main, you would, in fact, be branching off of here because this is now part of the main branch. We've merged it using fast forward. If you can't do that, let's say that feature 1 was taken off the second commit of main, but main now has a third commit. Well, now we don't have a direct line that doesn't leave out any commits. If we took the direct line, this guy would be left out. So you have to do one of two things. The most common thing to do is what's called a true merge. And with the true merge, you create a new commit that actually binds together your two branches. However, increasingly popular, instead of doing a true merge, is to do what's called a rebase. And rebase is designed to solve the same problem as a true merge, but you don't clutter up your history with all those extra commits. The way that this works is that when you say to rebase, Git will make a copy of each of these feature 1 commits and put them onto, and remember that rebase is always onto the main branch. So the first thing it'll do is change the pointer, and then it'll make a copy of all of the feature 1 pieces, commits. You now have a direct thread that goes all the way up, and rebasing is generally shown as a direct totem pole, but it amounts to the same thing. There are a number of things to know about rebasing. As I said, one of the advantages are that you get a cleaner history, and when you have many, many commits, it makes it much easier to understand what's going on. It is a good way to reduce conflicts between work you're doing and someone else is doing is if you rebase frequently. Remember that rebasing is happening locally. It's happening on your machine. You never want to rebase on the server because remember what it did. It copied over feature 1's commits. We refer to that as changing history. And if somebody else was working on that branch, you could cause havoc by rebasing on the server. So the way that you rebase feature 1 onto main is very straightforward. You check out feature 1, and then you say get rebase main. Now, what I recommend you do actually is that you check out main, then do get pull, which will bring down the latest changes for main, then check out feature 1 and say get rebase main. I would argue that you should do this very frequently, and that avoids having conflicts within the two branches from coming up or building up. It's very important after you rebase locally that you do not pull, because what you have rebased is different from what's on the main branch. And if you had conflicts that you had to resolve and you pull, you're just going to get those same conflicts again. Instead, what you're going to do, once you are ready to do a merge, and once you're ready to push this up to the server, is you're going to say push and use the flag force. And force means overwrite what is there with my current version. I know that my current version is right. Now that's a bit risky because you can overwrite someone else's commits as well. So I recommend that you always use -- force with lease. Force with lease says, go ahead and overwrite my work with what I have because I know what I have. But if you're going to overwrite anyone else's commits, then just fail. Tell me that you couldn't do it. Once you have done that, you're ready for a pull request. There is an entirely different concept called interactive rebase. It uses the same word as rebase, but it's really very different. Now, before we go to that, because we do have the time, let's build a little bit of an application, very simple application, and look at pushing and pulling and rebasing. So let's go back to Visual Studio. And when you remember that this is now both on the local repository and on the remote repository, we're going to make a change to this, very simple change, console.writeLine. This is another line. Am I a programmer or what? Okay, so we now have a change to the program. We can save that. We can run that if we choose. Let's do that. Make sure that I'm not crazy. Visual Studio being lightning fast. There we are. So it does work. It runs. It's worth keeping. So we're going to go back to the command line. Now, of course, you would never do this after one single line of change. I'm going to be making commits very, very, very frequently for demonstration purposes. Typically, what you would do is you'd finish a small chunk of work and then commit it. But I can commit this. The first thing I'm going to do, you'll remember, is get status. And that's going to tell me that I have one file that's been modified, this one. Now, I have two choices here. I can add that file and then commit it, or I can combine both steps by saying commit-a, and that adds the add step. And then I'm going to say -m, meaning I'm about to give you a message. And here I'm going to say add second line to main. And that would have been good if I had said get first. Every command has to begin with get. Okay. Now what we've done is we've taken the file that changed and we've committed it locally, and we've added a message about that. Now there's a command that we're going to look at later called log. You use log a lot. I'm going to show you very briefly log here because I want to show you what happened with those commits. And I'm going to tell it to give me one line. I think it's with a dash. No, it's probably not. And now you can see that we had our initial commit, and then we had add the second line to main. And this is where it's going up to the RVNUG project. A typical log, rather than one line, will give you more information about each of those commits. So you can see that, and they're in reverse time order. Here is the commit ID, which is a SHA. It's also a GUID. It's a unique number in hexadecimal. Here's the person who wrote the code that made that change, when they did it, and the message that they put in. And you can see why messages are so important. Remind me at the end when we're talking about aliases, and I'll show you the log that I like to use, which combines the one line and all the data that was there and shows you the short version of the SHA, the message, who did the commit, when they did it, and so forth. So we're going to get to all of that. All right, we now have a repo here that has that second line, but it's not yet on the remote repository. So if we were to go to GitHub and look at it, that second line would not show up until we push it. Let's do a little bit more work. Let's go here, and we're going to create a new class. So we'll say add, where are you, add class. And we're going to call that class calculator, my favorite class for demonstration purposes. And Visual Studio is going to go ahead and create that class for us. Notice it's over here as calculator CS, and it's over here where we see the code. I'm going to make that public. I have been arguing with the folks from Visual Studio that it should public in automatically for classes, since I almost never want a private class, but that's just me. All right. Again, I'm going to make my commits more frequent than I normally would. So I'm going to save that and make another commit. So I can say get status, and there is the modified calculator CS. And over here, I'm getting some good information. It says that you have one push to make, you added a file, you haven't modified any, and you haven't subtracted any. So we've added this new file. Another way that we can add that file, remember before we said get add and the name of the file, we can instead say get add and then just hit a dot, and that says anything that's not added, go ahead and add it. So now we have calculator.cs sitting in our staging area, and we can move it into our repository by saying get commit. And now it wishes I had a message. So I'm going to say create, because we want to put it in the imperative, calculator class. We'll save that, close that, and now Git will be happy and adds that to the repository. Now notice we now have two to push up. At this point, we might say, I'm worried that somebody else has modified main and that I'm going to have a conflict. So what I can do is I can change directories by saying get checkout main. So I'm not really changing directories, I'm changing which repository I am working with, which branch I'm working with, forgive me. And what that does is it modifies the working area. So if we look over here at Visual Studio, and we're in the main branch now instead of, oh, we've been in main, excuse me, I'm so sorry, it's late. We've been in main all along, we haven't made a branch. Okay, so we were in main all along. Let's go ahead and create a branch. So we're going to say get branch calculator. And then we're going to say get checkout calculator. And in that branch, now calculator, I'm no longer on main. I'm going to come up to the calculator class and create an add function or method. I'm going to say public int add, and that's going to take 2 ints, and it's going to return their sum. Okay, so that's pretty straightforward, and I'm going to save that. Now I'm actually saving it not into the main branch, but into the calculator branch. So when I say get status, it's going to tell me that I've modified calculator. I'm going to go ahead and say get commit, and I want to commit that directly. So I'm going to say -a, and then commit. Let me try that in the right order. Commit -a and then -m for the message, and the message will be add the add method. And that adds it, but it adds it to the calculator branch. Let's make another change. And we'll add a subtract method. So we'll rename that subtract. I didn't think I quite had it. And that will say left minus right. Okay, and then I'll come down once again, and I'll commit that. Okay, so I now have 2 on my calculator class, and I have not yet pushed up main. And I want to do a rebase of calculator onto main to make sure that I don't have any conflicts if anybody else did any work on main. So I'm going to change directory. I keep saying that. I'm going to change which branch I'm on by saying get checkout main. Now watch over here where our code is. When I check out main, I'm now get checkout, if only I could type. I'm now on the main directory, and if I come over here, those disappear because they're not in the main branch. And every time I say directory, please hear me say branch. So it's very important to understand why that happened. If I go back to the calculator branch, get checkout calculator, then if I tap here, they come back because now I'm on the calculator branch. What's important to understand is not only is Visual Studio reflecting that, that's what you would see in Windows Explorer. Those files are actually different depending on which branch you're in. Okay, we were in the middle of wanting to do a rebase, so let's go ahead and go back to main, get checkout main. Okay, and it tells me that my branch is ahead of origin by 2 commits. And that's right, we did not push those 2 commits. So let's go ahead and do that, get push, and that pushes up the 2 commits. And when it's happy with that, I'm now stable. If I say get status, I should see that there's nothing to do. However, before I do this rebase, I want to make sure that I have the latest code for main. So I'm going to say get pull, and that says go to the remote repository, and if there's anything different on main, bring it down to the local repository. So now we've pulled, and main is at its latest. So now we're going to go ahead and check out calculator. Now we're on the calculator branch, and we can rebase calculator onto main. And if there are any conflicts or problems, they will surface right now. So I'm going to say get rebase main. And what that says is I'm on calculator and I want to rebase it onto main. Remember, this is happening locally. Okay, it's up to date. I didn't get any conflicts. I can continue with my work on calculator, which has now essentially moved where it's branched off from. Originally, it branched off from main at a particular place in main. Now it's on whatever is the tip of main. Now, since there's only one programmer working and we only have one branch, it didn't really do very much at all. But if there were a couple calculators, if there were a couple programmers, and they were all contributing to main, then I very well might be pointing to a different commit in main. And by doing a rebase, I'm pointing to the tip that is the latest commit in main. Okay, we can go back now that we're on calculator and add multiply. And then I think we'll stop for now. I want to save a couple of things for demos as we go. And this will just say return left times right. Okay. And we come down here to our command line. And if I say get status, okay. Now we're going to go ahead and commit that. So I'm going to say get commit. Now it's not in the staging area, but I'll use -a, which effectively puts it in the staging area and allows you to commit -m, add multiply method. Okay, and let's push that. Now what it's telling me is I can't push it because Origin, that is GitHub, doesn't know anything about a calculator branch. But fortunately, it tells me exactly what to do. It shows me the command to say create a calculator branch on Origin. So we're going to grab that, copy it, and paste it, and enter it. And that pushes calculator up to the remote repository. Now we won't have to use that command again on calculator. We can just say get push because now it knows about it. And let's go back to GitHub.
I love how Git just reads your mind on what you want it to do or what you're going to do next and just gives you the command. I wish like old commands would do that. It's so nice.
It is useful. And in fact, if you use GitHub Desktop, it does an even better job of reading your mind, but it's somewhat limited. Okay, so here we are on main. And if I dive into here, all I see are these three. Calculator program, that's fine. But if I go into calculator, I only see the outline of the class calculator. And that's because that's all that's on main. And we only asked for main. If we come up here and say, I would like to see calculator branch, then we're going to see all of the work that we put into the calculator branch. Now, interactive rebase, I wish had a different name. The reason it's called interactive rebase is that under the covers, there's a great deal of similarity, but from a functional viewpoint, they're really totally different. Interactive rebase will allow you to take a number of commits and squash them together. It will also allow you to go in and reword the messages that you put into those commits and to remove and reorder commits. Now let's go back to our program so that we can see this. And unfortunately, I didn't save a couple extra commits, so we'll just do a little bit of quick creation of commits. So we'll say, let me have a divide, which is going to do integer division. And we'll commit that, we'll save that, and then we'll commit it. You don't have to do a status each time, but I just find it much safer to know exactly what I'm working with. Okay, that's one commit. And now we're going to come in here and add the modulus operator so that we get the remainder after our integer division. And I hope that made sense to you. And the way you do modulus operator in C#, let's call this modulus, I think that's how you spell it, is you use the % symbol. So we'll save that. And again, I'm making more commits more frequently than I normally would, but I'm going to use the up arrow and go to this commit and just change what the message says. I'm living dangerously because this time I did not do a status first. Okay, commit that. Now we've got a couple commits in there. We're going to use one more. And let's say we have this, and we're going to add division with doubles, true division. So we're going to call this division. And this time we need to change these all to doubles. And this will give you, when you do 5 divided by 4 on integer division, it's going to give you 1, because 4 goes into 5 one time. And it doesn't know anything about decimals. If the modulus operator actually gives you the remainder, remember 4th grade math when you had division and a remainder. By using doubles, we're going to get the correct percentage. So let's see, division, yep, that's good. And we're going to come down and make yet another commit. The status, and we'll say get commit a-m add true division. Okay, good. Now we have 3 commits to push up, but we did very similar things, all of a piece in those 3 commits, and they really all belong together. So that's what interactive rebase is for. If I say get rebase -i, which means interactive, and then I have to tell it how far back I want to go. Well, I know that I did 3 commits, so I'm going to go back 4. So I start with head, remember the head pointer, and I say head tilde 4. And it's going to open up my editor and show me the last 4 commits. And here they are. Each line says pick, which means included. Here's the short SHA, and then the message. What I want to do is I want to have division and modulus and integer all be 1 commit. I don't like that they're 3 commits. So on the modulus operator, I'm going to change pick to squash. And that's going to squash that one into the one above it. And I'm going to do the same thing here. And in fact, I don't have to say squash. I can just say S as shorthand. So what I'm telling get at the moment, there we go, is to squash this one and this one into this one. Let's go ahead and save that, close that, and it says waiting for your editor again, because this time it wants you to manage your messages. And instead of add integer division, add modulus, add true division, I'm going to change this to say add operators calculator. And if I could remember which ones I had, I would put in the specific ones. And I'm going to get rid of these other messages. Now, another thing you can do is leave those and they'll show up as an extended part of the message. But I'm going to make my message nice and simple. Add operators to calculator. Save that. What is twinging? Go away. Okay, save that and close that. Now notice that it now says that I have only 1 going up to the server. It was 3, but once I did the rebase, I only have 1. So I can now say get log, let's use my LG, and notice that it now says add operators to calculator. And that's what we're going to be pushing up to the server. Multiply and subtract we did earlier, but the division and the true division are all in this 1 commit. And as far as the repository will be concerned, there'll be just 1 commit for all 3 of those. So I'm going to say get commit. Let's do a status to make sure we know what we're looking at. And there's nothing there. So I must have committed it already, and I'm ready to push the one. So I'm going to say get push. And that pushed my 1 commit that contains the 3 I originally had up to the server. And that makes for a much cleaner history, because instead of having 3 separate commits that have tiny little things in them, I've been able to squash them all into 1 commit with 1 message that tells me what I did on all of that. An important thing to know about interactive rebasing is that it happens locally, and that you want to do your interactive rebase before you push. Here's a picture of what we just did. I don't know how to make this thing go away. But essentially we had 4 to push up. We did the interactive rebase, and then we had 1 to push up. However, you do this before you push to the server. The order of operations is something like this. Create your branch, write some code, commit fairly frequently, write some more code, commit, write some more code, commit, until you're ready to push. Do an interactive rebase to clean up those commits. Change your branch to main. Pull main, which means get the latest. Change your branch back to your feature branch and rebase onto main. Then start the whole cycle over. When you're done with your cycle and you want to do a pull request, the first thing you have to do is get your local changes up onto the server. So you're going to do a push force with lease. And that says take all of these interactive changes I made, push them up to the server, and overwrite what I had before of my work. And then you can do your pull request, which will merge it into main. How are we on time? We got about half an hour, up to half an hour. Is that right?
Yep, half an hour and a little more if you, if it takes you there.
Okay, we'll see if it's a little more, a little less. But here comes some nice additional features of Git. First of all is aliasing. Thank goodness we're up to this because I've been typing everything out. Aliasing allows you to create, as you might guess, aliases for commands. And you can create short, useful aliases rather than typing everything out. So a simple one would be this one. The way you create an alias is you say config, and then you say -- global. Now you can make it local or per team. 99% we use -- global. Then you use the keyword alias, followed by a dot, and then the alias you want. So in this case, the alias is CO, and that's followed by the command that you want CO to represent, checkout. Notice that if I go to my command line, I can say get CO main, and that checks out main. A little bit quicker. I use ST for status. I'm very lazy. And that gives me my status. Here's a couple others. BC I use for checking out, for creating a branch and checking it out. B for branch, C for checkout, which does both at one time rather than having to say checkout -B. Here's my LG alias that you saw earlier. The way this works is to manipulate the line using colors. So %C means begin a color, then in parens the color you want to use, and then whatever you're going to put between the color, which this is a short hash, and these shorthand tags are just something you look up, and then %C rest, which ends the color. Then we're going to have a vertical bar and so forth. And rather than having this looking log, we instead have this. And so the one on top has just one commit, and it's a little bit wasteful of space. Here we have two commits, very clean, and we get more information, in fact, because rather than just getting the date, we get it computed as to how long ago that was. So that's using LG as my alias.
That's much better to understand what's going on when you're looking at very, I think there's like a one-line option there you can use too, but it's a lot more terse than this one-liner.
We actually looked at that. We can look at that again. Let's you can go, instead of saying, you can say get log. Okay, you can say get LG, that's the one I created, or you can say get log and then give it the one line flag, and that gives you one line for each entry, but not as much information as the one that I created. So you have lots of options with log. In fact, you have lots of options. It's like the
perfect combination. I think the one line is a little lacking in understanding what's going on, and then the standard is too verbose, and you really don't want that multiple line. You really want as much information expressed as possible in one line to that's the best of the world, and I love that. I love your alias there. I'm definitely gonna steal that, Jesse. Just to
it's okay. I stole it from someone else, so no problem.
Nice.
Okay, another thing that I want to point out to you is that we're doing this get config global. That's writing to a specific file. You can get to that file, get config, by saying edit global one. And this is just a file on your disk. And inside that file is configuration information. I'm waiting for code to open up. Why is it taking so long? What's going on, code?
Is it already open?
It's confused. All right, let's close this one. Here we are. Now there's some things in here that I'm not going to go through, but for example, here's where you would locate who the user is and what their email is, and that's how things are stamped. You can see the author and the email. And then here are all my aliases. Now the syntax in here is slightly different. Here we put the alias equals and whatever the command is. This is what gets written when you create your alias. If you say get config -- global alias.st and then status, what gets written is in this file st equals status. There are some other nice things in here that we're going to get to in a little bit. Okay, let's go back to our slides. One of the aliases that I highly recommend, you'll remember that I said that you want to use push force with lease so you don't overwrite anybody else's. I created an alias called pushf, and by using that, I know that I'm going to get that force with lease. I'm not going to forget to do so. Log. We've looked at log a little bit, but log is a very, very powerful command. It has many different flags and options that you can use. We did look at one line. There's name only, which gives you the names of the files that change in a particular commit. You can say -1 to get your previous commit, or you can say -2 to get your 2 most previous commits. -p will show you what changed. I don't find this to be a terribly reliable command on log. There are others. Get show is, I find, a more useful way to see all of the things that changed. And if you just want to see what's the difference between what's in this commit and was on the previous, or what's on the branch before you made your changes, you can say get diff, D-I-F-F, and that will show you the difference between what you're about to check in and what's already there. Let's take a look at that, since I'm not sure I explained that as cleanly as I might have. So let's go back to our code. And we're on the wrong branch. We can see that because everything's missing. So yes, we're on main. So let's say get CO for checkout calculator. Okay, and now we should see everything come back. Yep, there it is. And let's add one more. And we'll use square root. I hope I remember how to do this. This is going to be double value. And I believe we just say return math dot square root of value. Look at that. Okay, it's happy, so I'm happy. We'll save that, and we'll go back to the command line. Now you'll remember that what we were talking about was the idea of what's changed, and I was suggesting that the diff command might be a better way to get to that information. We just made a change, but we walked away. We don't remember exactly what's in that change. We say get diff, and it's going to show us exactly what changed. And what changed is that we added these in green. If I had deleted, let's go back and do that. If I had said, well, I don't want true division, so I cut that out, save it, and added, I don't know, is there another, can you think of another one for me? What does math have?
Exponent.
Return math dot pi. We'll do pi. All right, so we're going to call this get pi. And I did that on purpose because I love pi. Return math.pi. Okay, so that's another method. So I deleted one method, I added one method. If I go back to my command line, let's clear that so it's not confusing, and say get diff, it shows me, oh, you deleted double division and you put in its place square root. You deleted left modulus right and put math square root value, and then you added this whole method. So it's giving you a line-by-line distinction of what's changed in the file, and that can be invaluable when you're about to do a commit and you don't remember what changes you made. Before you make the commit, you can grab this. There are also things you can do after you make the commit. There isn't even things you can do after you've written from your local repository to the remote repository. There is a great many methods that you can use, flags that you can use in Git or commands that help you undo whatever mistake you've made. So it's, as I say, it's very hard to really actually lose data. It is, however, suggested that if you appear to have lost data or you made some terrible mistake, that you stop, because doing more can absolutely mess you up, and you go get somebody who has a lot of expertise in Git, and they will be able to recover it for you, and then soon you will feel totally confident to do that yourself. Okay, we can say what changed in a file over time by giving it the file name. Let's see if we can do that. I sometimes had some trouble with that one, but we're gonna take the chance and say git log calculator.cs, right? Oh, but it's going to want, no, I think that's all right. It's just going to want this whole path. So we'll say RVNUG calculator.cs, copy that, paste it, and it shows you everything that happened to it, which is great. It says you added the operators, you multiplied, you subtracted. And what would be interesting here is that if you had other classes that you had worked on, and we had the main class, they're not going to show up because you specifically asked for the history of this class. Anytime you're in something with log or anything that's displaying at length, you can hit Q to drop out of that, which is what I just did. And clear says I want to start with a clear screen or clear skin. Let's go back to our slides. Okay. If you want to search for a word within all of your commits, you do --S and then whatever the word is. If you want to know all of the commits that were made by a particular person, you can use --committer as you see here. And you can even use that with a since flag, and you can use virtually any normal text that you would expect. So since 3 days, since 1 week, since, and so on. We don't have enough here to show you since 1 week, since we did everything tonight. Okay, if you're sitting and you have some files that are staged and you no longer want them to be staged, you want to go back and put everything back before it was staged, then git restore --staged, you can either put in the file name or you can put in a dot to do all of them. And that will take them out of the staging area, put them in the work area, and make no other changes. However, if you leave out the --stage flag, whoops, and just put a file name, then it's going to be removed not only from the staging area, but also from your work area. That is to say, that file is going to be brought back to the state it was in before you made any changes since your last commit. That's obviously a dangerous thing to do. This is one place where you actually can lose data. However, it can come in extremely handy. Let's say you make some changes to a file and you really just mess it up. And you don't want all the changes you made since the last commit. You don't want any of them. You wish you could go back to the last commit with this file. All you have to do is say git restore in the file name, and boom, you're back in that file to where you were before you made any changes since the last commit. You can use wildcards here. You can use dot to restore all the files in a directory. I would be extremely cautious with that because they're all going to be reset back to the previous commit. Oh, somebody else has a dog too. Very cool. Git show shows you what's in the commits, and git blame is one of my favorite commands. Terrible name. What git blame does is it goes through a file and tells you who made each change. Now, this is not going to be terribly meaningful because there's only me. But if we say git status, okay, and let's say git commit. Oh, I have an alias for this, git-scm, which is commit with the A flag and the M flag. And so now all I have to do is put in add square root. And that's going to do the same thing as having said get commit -a-m. And now I would like to know, I'll come back later, and I'd like to know who did what to the calculator class. So I can say get blame, And I'm going to need this whole path. And here are all the changes that were made, when they were made, who made them for each line. Now, if you had more than one programmer, these could flip between different people. Oh, Jesse changed these 2 lines, but then someone else changed these lines, and so on. So Blame can help you a lot with figuring out who made a change so that you can go to them and say, help me understand what this one was, or you can go to them and say, you broke my code, you moron. Never do that. But it is a good way to find out who made each change so that you can understand the sequence of changes that happened or why you're getting conflicts and so forth. It can be very helpful in resolving conflicts. That's not what I wanted to do. No, I don't want to do that. I want to do this. Git diff we talked about. If you have a branch that you don't want anymore, let's say it's just dead, you don't want to pursue anything on that branch, you can use get branch --d followed by the name of the branch, and that branch will go away. Once again, this is permanent, and so this is a place where you can lose work if you delete a branch that you care about. Instead of just adding to the staging area, you can do it interactively with add --i. Okay, there are some other commands that can help you very much with understanding what's going on. The middle one is extremely important. Let's say you're on the main branch, you checked out the main branch, and then you started work, and you committed it to main. Well, that's not what you want, or before you commit it. You realize I've made these changes and I'm on the wrong branch. Well, if you do a get reset --soft, and then you put head with a tilde, what that does is it takes them out of the commit, takes them out of the staging area, but leaves them in the working area. You can then change your branch. They're still in the working area, and now you can commit them in the other branch. This is a wonderful PowerShell script that I just got from somebody today that says, go find all of the branches on my machine that are not on the server, which means presumably I deleted them from the server but forgot to delete them locally. And this will go through and delete all those local branches that are not on the server. And when you are creating dozens and dozens of branches and then doing pull requests, deleting them automatically on the server, but forgetting to delete them locally and making a big mess of branches, this can be a real lifesaver. Let me see what kind of time we have. I think we will wrap up with bisect. Bisect is a great command for finding errors, finding which commit has the error. Let's say you've made 20 commits and you notice that it's not working. So you look at the previous commit, it's still not working. Uh-oh, where did this break? Well, you use bisect. The commands are get bisect start, that starts the process, and then get bisect bad. And that says my current commit, my latest commit is not working. And then you find the SHA of a commit that's known to be good, like last Wednesday, and you put that in as get bisect good. And you will see it say something like this: bisecting 920 revisions left to test after this one, which will take roughly 12 steps. So we really have a lot to go through. You test the version that bisect checks out for you. If it's good, you're done. If it's, if it's bad, you're done. That's the current, excuse me, I'm saying this very poorly to you. After you get the version that bisect checked out for you, you look to see whether it's good or bad. If it's bad, you tell get bisect it's bad, and it's going to do another test for you, cutting the remaining revisions in half. Sooner or later, you'll run out of commits, and at that point, bisect bad will point to where the problem is. Once you've found the problem, you enter get bisect reset. I didn't explain that terribly well, but get bisect is worth reading about. It is a very powerful command and does help you find where your bad commit is in a series of commits. Oh, great. We're towards the end anyway. There is the Git documentation online is excellent, but it can be a bit technical. And I recommend when you Google for a particular command that you not only look at the official documentation, but there are other sites that give examples and make it a bit easier to understand. Let me give you an example of what I mean by going back to our browser. If I go open a tab and I say get and then log, what's going to come up is the official Git documentation. When I look at that, it has a synopsis and a description. The description is a little technical, and then you get into all the options. Now, some people just love this. It's terse, and it's exactly what you want. If it's not what you want, if it's not making sense to you, then there are lots of other places that have tutorials. Atlassian, which owns Bitbucket and also has a GUI called Source Tree that works with Git, has a great tutorial. And so you can look up, for example, get log there, and they're going to have a more conversational approach to showing you what log is and so on. And we'll give you examples and so forth. So there's a lot out there worth looking at on the web. There are also blogs, a number of very good blogs out that can help you with Git. There are podcasts. I don't know of any that are dedicated to Git, but some dip into Git. And there's my site, which I was running a number of articles on Git, but I'm not now because I'm actually under contract to write a book on Git. So that will be coming out this summer. So what I recommend is that you don't learn any Git and you wait until this summer and get my book.
Awesome.
And that's what I have. So thank you very much.